Okay, yesterday we introduced you to factoring, but we only factored trinomials whose lead coefficient was 1. Today we're going to continue factoring, but the lead coefficient of these trinomials is going to be something other than 1. Could be a positive or a negative. We'll focus on integers though. A lot more complicated when this is the case. To factor these trinomials, we're going to find values of d and e. Hold up. I'll explain what d and e are, such that d times e equals a times c, and d plus e equals b. Then I've got this formula for you that we can factor. Ax squared plus dx plus ex plus c. We're going to call this the AC method. Because the first thing you do is multiply a times c. All right, so here we are. A trinomial, 3x squared plus 5x plus 2, and the lead coefficient is not 1. So we're looking for factors, d and e, that when you multiply them you get 6, and when you add them you get 5. Okay, d times e, we get 6 from the 3 times the 2. That's always the first thing you do, 3 times the 2. We're going to do this several times, so it's always going to be the same thing. It's called the AC method because the first thing you do is multiply a times c. 3 times 2 is 6. As far as the 5, it's just always the b value. So this is very much like the method we did in the last lesson at this point now. What numbers that when you multiply them give you 6, and when you add them you get 5? About 3 and 2. Okay, 3 times 2 is 6. 3 plus 2 is 5. Again, we're going to do this several times. Follow along for now, and we'll give you a shot later. Then I've got this, what looks like a rather complicated formula. It's ax squared plus dx plus ex plus c. And we'll start plugging in values. Both values from the original trinomial and values that we just found. Okay, a is 3. It's right here. D, we just found it. It's 3. E, we just found it. It's 2. And by the way, it does not matter if you mix up the 3 and the 2. If you do them D and E and D, it doesn't matter. And C is this 2 up here. Okay. At this point, what we're going to do is reverse distributive property. You guys all know how to distribute a number through. All we're going to do is take it back out. So what common factor do 3x squared and 3x have in common? Obviously, they're both divisible by 3. They both also have an x. So when I do reverse distributive property, I get 3x times x plus 1. Okay, and you can check it by doing distributive property. 3x times x is 3x squared. 3x times 1 is 3x. Over here, we got to do the same thing. Both 2x and 2 are divisible by 2, so take a 2 out. And you can check it by doing distributive property. 2 times x is 2x. 2 times 1 is 2. We've all but got this thing factored. You'll notice the x plus 1 that is in both places there. That's one of your factors. The other factor is these numbers out here that we took out, the 3x plus the 2. Okay, so we've done a lot of work here, but this x plus 1 times 3x plus 2 is the factorization of 3x squared plus 5x plus 2. We took this original trinomial and we factored it. We'll go through the process several more times. But let's take the time on this first one to check our answer. X times 3x is 3x squared. X times 2 is 2x. 1 times 3x is 3x, and 1 times 2 is 2, and we can combine like terms. You'll notice that this trinomial, 3x squared plus 5x plus 2, is the original trinomial, so that this is the correct factorization. It's a lot to handle. We'll do it a few more times. Here we go. Here's our original trinomial. It's called the AC method because the first thing we do is multiply a times c. 2 times negative 11 is negative 22. And d plus e is going to be our b value, 21. Okay, so we're looking for factors of negative 22 that add up to 21. First one you check, probably, you'll notice, is the correct answer. 22 times negative 1 is negative 22. 22 plus negative 1 is 21. So that's the toughest part. At this point, it's really all going to be procedure. I've got this formula for you. Ax squared plus dx plus ex plus c. A is 2. D is 22. E is negative 1. And c is negative 11. Okay. Now we'll factor out the greatest common factor. 2x squared and 22x are both divisible by 2x. Negative 1x and negative 11, we're always going to pull out that lead coefficient of the negative sign. So let's divide both sides, or take a negative 1 out of this, I'm sorry. So it's going to be negative 1 times x plus 11. Okay, and again, if you distributed this back through, negative times x would be negative x. Negative times 11 would be negative 11. So that leaves us with our answer. X plus 11 is one of the factors. These should always be identical. The other factor is 2x, and this is minus 1 right here. It seems a little bit complicated. You're going to see that it's very repetitive. All right, let's do this again. First thing we do is 8 times negative 15 is negative 120. Negative 14 is the sum of our factors. Okay, so this one's a little bit tougher because negative 120 is a little bit bigger number, but remember, I'm looking for a positive and a negative number. That's the only way I can get a negative factor. The bigger of the two's got to be the negative number. So I'm going to list some factors over here. 1 and 120, no. 2 and 60, no. 3 and 40, no. I'm looking for numbers whose difference is 14. 1, 4, 5 and 24, 6 and 20. There we go. That'll do it, because the difference between 6 and 20 is negative 14, or is 14. So the bigger one I'll make negative, and the smaller one I'll make positive. Negative 20 times 6 is negative 120. Negative 20 plus 6 is negative 14. Then we've got this formula. That's really the toughest part, is identifying what D and E are. A is 8. D is negative 20. E is 6. C is negative 15. What can we factor out of this? They're both divisible by 4x. What can we factor out of this? They're both divisible by 3. Magically, both of those become the same. 4x plus 3 is our other factor. One thing to keep in mind, too, is that not all trinomials are factorable. If you're having trouble, maybe it's because the trinomial you're trying to factor is not factorable. You can always check the discriminant. If the discriminant is a perfect square, it's factorable. If it's not a perfect square, it's not factorable. Let's do one more before we get you guys trying it. This one's a little bit different, because the first thing I noticed, and hopefully you guys will be on the alert for this as well, is that all 3 of these terms are divisible by 3. So we can actually undistribute or factor out the greatest common factor right off the bat. So 3 times 2x squared is 6x squared. 3 times 3x is 9x. 3 times negative 9 is negative 27. If there is a greatest common factor that you can pull out first, you should do that. Okay, now I'm looking for factors of d times e. Remember, or I'm sorry, a times c. A is 2, c is negative 9, so it's negative 18. And our b value is 3, not 9. We're looking at our new trinomial. So how about positive 6 and negative 3? Positive 6 times negative 3 is negative 18, and positive 6 plus negative 3 is 3. Here's our formula. Remember that we're using the values of this trinomial after we took the greatest common factor out. So a is 2, d is 6, 3 is negative, or e is negative 3, and c is negative 9. Factor out of 2x out of the first. Factor a negative 3 out of the second. Remember, you can always check this by doing distributive property too. Negative 3 times x is negative 3x. Negative 3 times 3 is negative 9. We get what is almost our complete factorization. X plus 3 is in both of these. That's one of the factors. 2x minus 3 is the other. Don't forget this 3 up here. Okay, that is part of your factorization too. If you just leave it as x plus 3 and 2x minus 3, you won't have factored this trinomial. You'll have factored only this. We need the 3 there too. It's part of the factorization.